So here, a general power series is represented by this. Some sequence, and then times x minus c. That's going to be the center. We saw that with Taylor series and Maclaurin series. Maclaurin series are always centered at 0, and Taylor series can be centered around any c value. So that's just the general form of a power series. And for problems that look like 1 over 1 minus x, if you're trying to figure out a power series representation of functions that kind of look like that, and they say centered about 0, then that just means you have just a regular constant, right? That would be a geometric series. If it wasn't a constant, it would be a regular power series. But I'm not going to say c, I'm just going to say k. And then x to the n, because c would be 0. So in your exercises, it says centered at 0. That just means this part is 0. And also, when you're trying to find something that looks like this, trying to find a power series for something that looks like that, this is not going to be a sequence, it's going to be just some number. So hopefully that helps you a little bit. Yeah. Alright, so let's take a look at another example. Find a power series for this. It's going to be centered at 0, c equals 0, but don't worry about that, because I just use this form and that geometric series theorems that I have. So let's take a look. This almost looks like 1 over 1 minus x. I mean, not quite, but I can manipulate things so that it kind of does. So that's what I'm going to do here. And I guess I'll write it in green. 1 over 1 minus something. That's really what I want. 1 over 1 minus something. And then in here can be anything, because I can substitute it in my geometric series. Maybe I'll write that as well, just so that you have a picture of it. Yeah. That's what I'm looking for. Something on the inside there, because those things are missing. So if I can get it to look like this, then I can immediately make it into a power series. That's my goal. So that's always going to be in the back of my head. So let's start working on this. I'll do it in red. So I want a 1 there. This is already good. That's already a 1 on the top. Fantastic. So I want to make this a 1. Let's see how I can do that. I can force factor out a 2, and then I have 1 plus x squared over 2. Factored that out, and that's the same thing as 1/2 times 1 over 1 plus x squared over 2. So I have that part. Okay, I still need that minus, but I can change that. That's very, very easy. So 1/2 times 1 over 1 minus negative x squared over 2. So I have my 1, another 1, another 1, and something there. Great. So now I can write my series. So I'll do that, and I'll do it in green. So I have the series from n equals 0 to infinity of, well, what's my something on the inside there? That's just negative x squared over 2. So I can say negative x squared over 2. Not squared, sorry, to the n, right? I literally got 1, 1, and minus. 1, 1, and minus. Then, as soon as I have that, I can go to my power series representation. Except for, I have a 1/2 on the outside. So, I'm multiplying this whole thing by 1/2. But I mean, that's hopefully just to get you to understand, but I'm actually going to do something a little bit different. But there's my power series representation. Now I'm going to simplify it a little bit. But I know that the negative square root of x over 2, that's my r value. So that has to be less than 1. This will help me come up with my interval of convergence. So I have that. Now let's simplify. The 1/2 I'm going to bring to the inside there. So I have the sum from n equals 0 to infinity, and to infinity and beyond. There's like infinity And beyond infinity? What is that? I don't know. I don't know. Okay, so I'm going to kind of split this up. There's like a -1 there, so I would have -1 to the n and x to the 2n, right? Because I would distribute that kind of, you can think of it as distributing. And then 2 to the n on the bottom. Now this is looking like a crazy power series. But those have the same base, so I can combine those. N equals 0 to infinity. And I have a -1 to the n times x to the 2n on top, divided by 2n plus 1. Now that looks like a legitimate power series. It's like, oh, I feel smart. That's very nice. So, there's my power series. Now I want to know the interval of convergence. Well, that comes from this. So this implies that, well, the negative that can go away because I'm taking the absolute value. So the x squared over 2. That has to be less than 1. But I can multiply both sides by 2. This is always going to be positive 2. So this implies that x squared is less than 2. So what things can I put in here? And actually, I don't even need the absolute value because it's always going to be positive anyway. But x can be the square root of 2 because the square root of 2 squared is 2. So I can say negative square root of 2 all the way to square root of 2, right? Because that'll give me my stuff. All right, so my interval convergence, there it is. And that's all. That's my power series representation with my interval of convergence. Now, I don't include these because for a geometric series it has to be strictly less than. If it was equal to 1, it wouldn't converge. Hopefully that's pretty simple. I'm going to do another example, I think.